In 1845, a German scientist with the name Gustav Kirchhoff developed his own rules based on the principles of Ohm's law to enhance our ability in calculating components of electrical circuits. He established what is known today as Kirchhoff's laws, which calculate currents, voltages, and resistances of electrical networks. His newly discovered rules were also inspired by the law of conservation of energy, which states that energy cannot be created nor destroyed, but can only be changed from one form into another or transferred from one object to another. Thanks to his discovery, we now have the ability to calculate the amount of current or voltage entering a node or leaving a node, as well as the ability to determine the right components to put in a given circuit. This became a huge factor in paving the way towards the digital age and made it possible for us humans to become the technologically advanced race we are today. Kirchhoff established two rules in circuit analysis. The first one was the junction rule, or commonly known as Kirchhoff's current law, or KCL.
See you later, guys. As always.
Yes. Let's meet up later. Hey, I'm glad we all have the same lunch.
Not for us.
Yes.
Blood or pressure is strong.
What do you mean by that?
Even though we haven't talked.
Alright, it's just like the junction of
Kirchhoff's current law states that the sum of all currents entering a node is equal to the sum of all currents leaving the node. In other words, it means that everything that comes in must come out. It is given by the formula I sub 3 is equal to I sub 2 plus I sub 1, wherein I sub 2 plus I sub 1 are the currents entering the node, and I sub 3 is the current leaving the node. For example, when 3 students pass through an intersection, the number of students who entered that intersection must be equal to the number of students who exited at that same intersection. Similar to electrical circuits, where current can't just disappear out of nowhere. The second rule Kirchhoff discovered was the loop rule, or otherwise known as Kirchhoff's voltage law, or KVL.
I think STEM is the hardest one ever.
Why don't you guys try to compute and tally all those things, huh?
Nice, chill. PBMS is the hardest. You mean doing push-up is hard?
It's like you're just lost.
What? Oh, you mean we meet again?
Yeah. I don't think that someone or somebody can transfer our friendship.
It's okay. I know you're struggling.
Kirchhoff's second law states that the net electromotive force around a closed circuit loop is equal to the sum of all potential drops around the loop. It is given by the equation the summation of rise is equal to the summation of drop, meaning if you add up all the voltage rises and voltage drops in a circuit, the sum must be 0. In this example, a circuit connected in series shows 3 resistors with their corresponding values and 1 battery. Assuming that the direction of the circuit is clockwise, if you add all the voltage drops when it passes the resistors, with the voltage rise when it passes the battery once again, the sum should be equal to 0. Similar to how a strong friendship works, there may be ups and downs along the way, but at the end of the day, all of those don't matter, because you'll always find your way back together.